Welcome back to Quick Python number 7 with PageKey Solutions. Today we'll be doing an easy web request, and it will be our first foray into interacting with the internet using Python. As always, we'll follow our learning checklist, starting with why we would want to do this, proceeding to what we will be doing, and how we can accomplish it. The why for this one is very straightforward. Web interaction opens up an entire world of possibility. The big one is API access. Lots of applications, websites, companies provide web APIs to access their data. And this first bullet leads to the second two. You can do things like data mining, where you're automatically sweeping the internet for different types of data, downloading it in mass, and processing it in some custom way to give you insights that you need, or automation, where you can actually control things using scripts. So if, for example, a website provides a web API for social media, like I think Twitter bots, I've never done that, but I would assume that that's done through a web API where you can send commands using any language you want, in this case Python, and control things on that website without interacting with them yourself. You let the script do the hard work. Okay, so starting out, if you cloned our education repository on GitHub, you can just cd into the Quick Python directory and go to number 7 for this tutorial, the web request. We'll see 3 files here. The first one is, we'll talk about requirements first. You'll see requirements.txt, what's inside of it, just one package. You'll see requirements.txt everywhere, and what this is requests is a library that allows us to make web requests, but it is our first time using a library that is not bundled with Python when you install it. So this is an external package, and we're going to have to install it ourselves using pip. So we'll do pip3 install-r requirements.txt, and it will go through every single one in this file. Usually it's a pretty big list of requirements if you get onto a larger Python project. In this case, we just need one package. So it's going to, we'll say install, and of course I already installed it, so it didn't really say anything. But for you, it should go out and grab that package with a little process bar, and we'll be good to go. All right, so we've installed requests. Now we can run our examples. So I'll do Python 3.1 program simple. It's going to ask us for a URL, so I'm going to say linebylinecode.com, and 200 means request was successful. Anything with a 2 in front of it is success. And yeah, let's look at the body. Lots of stuff. That is the source code of our website, so that's cool. Now what if we gave it the wrong URL, or something that's not even a URL? This is not a URL. Somebody doesn't know how to use this tool, so they put in the wrong URL. It fails out. It says perhaps you meant something else. It didn't work out for us. It just failed in a very ugly way. So we also provided number 2 here, where we handle that a little more gracefully. It actually prints our own message instead of the entire stack trace. You can tell that, we handled it gracefully. We still said program finished and all that stuff. So we'll show you how to do that. But also, just as a proof of concept here, or just to prove that this still works with a regular web address. It's not like we removed that functionality or did something behind the scenes. It's 200. You say yes, you get the source. So number 2 works exactly the same, just a little more elegant with the way it handles the input. Always important. So let's get into how we can do this. So our 3 files for today's example, we already talked about requirements, nothing exciting there. I'll close that out. And if we go into our first program, what are we doing with this? First of all, we import requests, because we're going to need that to do our web request for us. And we just grab from the user their URL using input. We've gone over that before. And here's the part that actually makes the request. We say r equals request.get URL. If you don't know anything about like HTTP and how all that works, get is one of the methods that we use. It's probably the most common method. It's what you use when you just want to grab a page. You're not submitting any data. You're not trying to edit anything or delete anything. You just want some data. So we're requesting that URL that the user put in. We print out the status code. This is where you see that 200 come out, so you know if it succeeded or not. If you get a 404, I'm sure you heard of a 404 error. If the status code is 404, it's not found, and there's a whole number of HTTP status codes. You can always Google that and look them up. There's probably over 100 of them. I don't know. But yeah, the next step is we're going to ask the user if they want to view the request body, and basically we just force them to say either Y or N. And if they enter anything else, they're going to be stuck in this loop here. So that's nothing special either. We're just making sure that they input Y or N. If they said to continue, then we print r.content. Otherwise, user chose not to print content. I didn't even show that part, but that's no fun anyway. So try it out yourself if you want to see it print that enthralling message. All right, so that's the first one, no error handling, and we saw that this fails out if we enter an invalid URL and it can't get it. If it's just like a sentence, like I like dogs or something, it's not going to know what to do with it. How do we handle that? So in number 2 here, this is going to be largely the same, but we imported some of the errors that we saw when we ran with a failing code. You may be wondering, where do we figure out which things to import? In the stack trace, when it throws the error, it tells you that it threw requests.exceptions.connection error. So you just have to look at the stack trace. Then you can import these errors at the top of your file, embed everything into a try, and then you can add except blocks for connection error, for missing schema. This is the one that was thrown when we put in like a sentence or something. Connection error would be it's not a site, like you enter something.com and either the server's not up or it's not even a real domain. So it's a valid URL, but there's nothing there and it can't connect. So those are the 2 errors that we're handling, and we have a finally block that I'm sure you saw, and it prints program finished. So this is always nice. This is a try except block, so you can try something out. Any errors that are thrown inside of this block will first be checked against our except blocks. Is there a specific error for this? You can also have an except block without any specific error, but I don't think that's recommended. You should really try to put some kind of error there, and then the finally block always gets executed no matter what happens in the try block. It could explode, the computer could fall down a flight of stairs, and it's still going to execute this finally block regardless of whichever exception. It will handle the exception if it can, but then after it's done handling all exceptions, it will always execute the finally block. So we've gone over error handling in the past. Now you can see how it's applied and how it can be useful. Thanks for watching. Hope you enjoyed making an easy web request. If you want more, check out linebylinecode.com. That's our coding blog, so we have all kinds of articles and videos that are much like this one, more notes than we have in this video, and plenty more, so check it out.